Thank you, colleagues. Welcome to the Graveyard Shift. Uh, just before I start, and thank you, that young lady there, I just read her PhD proposal. And I'm not saying this because she's sitting here. I actually called and I told her this. It was the best proposal that I've read in many, many years. So congratulations to you. I'm looking forward to reading your work. The CEO and I started this morning. We had a brief discussion about all things like we always do about digital. And one of the things we spoke about was, the horrible demise of AKA. And one of the things that arose out of our conversation was the following: that in grief and in desperation and in sorrow, we've been sharing videos of the unfortunate event. And the conclusion we made was that as Namisa and as captain and as digital influences in the country, we have a responsibility to remind people not to do these things. Number one, because it's immoral. We are perpetuating the grief of the family. Number two, it's illegal. We are getting in the way of the investigations. And number three, it's a form of vigilantism, which is an online vigilantism. And we are wrongly and erroneously accusing people. So there are at many levels is wrong. We can understand the grief, we can understand the sorrow. So please use your influence and help the family and help the police to eradicate these messages, however well-intentioned they may be. So thank you for that. Ladies and gentlemen, I just want to remind you that the future is now. In 2018, Stella and Bani Abrahams took a young student to Parliament, and the minister said that this is the future of data science, and she flew Yassen Khan from Durban to Parliament. Didn't fly me, mind you. I was quite upset about that. And flew him and introduced him from the gallery as the future of data science in the country. And I think her words have proved to be really prophetic, because after that, he wrote 2 Web of Science papers on his master's. He's now completed his PhD and already has 2 journal papers and 1 Web of Science submission. And he's done incredible work. So I'm just going to give a brief context, because I think that the job of a supervisor is to be in the background, not in the foreground. So how many of you have heard of Chris Messina? Okay, Sebukela is Googling it already. Okay, the year was 2007 when Chris Messina accidentally looked at this hashtag symbol and said, maybe we can use this as, to kind of talk about, to highlight words and make keywords, or as we computer people call reserved words in a particular conversation. And that keyword and reserved word suddenly became an aggregator. So people started looking at different conversations, but they were connected by this search technique that you could get 2 conversations connected by hashtag. So whatever the hashtag was, the hashtag peace must fall, as in Yassin's case. But then, of course, it got more and more complicated, because then you could join more and more conversations. So it became just as noisy as we are in a cafeteria, isn't that so? And then therein lies the joy and opportunity and pain of doing social media research. So what we decided to do was to do an introduction to natural language processing today. Talk about English, talk about social media, talk about tweets, talk about how you break it into into what we call tokens, and see how we can start parsing conversations to make sense out of it. So English is horrible. It's a really bad language. It's the most unstructured language out there. It has understatements, it has wit, it has oxymorons, it has sarcasm. An oxymoron would be like Osana is a nice guy. That just doesn't work, right? So I know there's a talk on COVID tomorrow on sentiment analysis. I want you to think about the approach that Yassin has used. I don't even know about the talk tomorrow, so I'm going to preempt it and make one suggestion to you. As Yassin talks about a longitudinal analysis of sentiment, in other words, how do people feel about something over time, I want you to think about before tomorrow, when the young people present their talk on COVID sentiment analysis, what will be the points in that conversation, in the tweet conversation, that either promote a positive event or promote a nasty event? Or is it the other way around? Does a spike in tweets itself promotes violence or happiness or sadness or joy? You get what I'm saying? Sometimes a tweet or a viral tweet causes something, or sometimes the consequence of something causes something to go viral. The demise of AKA hashtag AKA, right? So his untimely death promoted a viral amount of tweets. Sometimes it's the other way around. Fees must fall created another effect, which was the reduction in the fees of students. So I want you to think about cause and causation and cause and consequences in that. Yassine, over to you, young man. Okay. You also got to be thinking about fake news, right?
Good. We need to make Mike's AI now. Must move on its own. That's fine. Okay. Good afternoon, everyone. Thanks for the introduction by my supervisor. I think he made an error that I complete my PhD theoretically. I still have to submit it, so that's just in the process. Colin covered the hashtag, how everything is aggregated. I'm just going to go to my section. So analyzing sentiment of hashtag fields must fall tweets. I just apologize that it was not an interactive session where I could go, for example, like how the next session is RStudio and we can do it online. I was sort of briefed that I just have to present this thing, maybe next time. So I've gathered some tweets, Twitter or data from a social media platform known as Twitter. Let's just give some background to those people who do not know. It's a free social networking site where users broadcast short posts known as tweets. I mean, if you come across Elon Musk, you will know about Twitter by now. One of the key things when we are doing our research is that compared to other platforms at that time, it didn't have easy way to firstly access the platform, secondly, get historical data, and thirdly, track particular events, which Twitter actually was doing better than the others. Recently, I think other platforms now, you with certain hashtags you can, and certain other metrics. So when we got the data from 2015 to 2017, when we cut off our study, you notice that the distribution follows what is known as a log normal. This is probably in certain literature, this is the norm, and our study shows that this is particularly the case as well. Here is a snapshot of what transpired. We got the data set, it went through some pre-processing, which we'll show later on, some NLP pre-processing. We use the Veda algorithm. It's basically a lexicon-based algorithm, and it gave us some output with some sentiment. We had to create some parameters for it to then denote what particular tweet goes as negative, positive, and neutral. You play around with the parameter. So Veda is a lexicon and rule-based sentiment analysis tool that is specifically attuned to sentiments expressed in social media and works well on text from other domains. At the time of the research, this particular way was the best. A lexicon-based approach was adopted due to the fact that in machine learning, you need pre-labeled data first to then train it and then predict. And at that time, it was restrictive to particular domains in machine learning. Later on, at this particular stage, a few years down the line, we have things known as transformers, which you probably don't need then to use lexicon-based approaches. Here's some of the code, which will be available upon request. The way you can get the data, we analyze it, we produce some sentiment polarity scores, and we plotted it. And key things to note about the plot, the yellow is just the volume. Obviously, in the beginning, it tends to be quite high. And then after it had a resurgence in the following year, because there's no particular outcome. And there was some unsavory events, particularly in September of 2016, the UKZN burning, UJ burning of lecture hall. What we wanted to know was, okay, people were speaking about this. Were they angry? Did they mention anything that maybe could have gave us a clue that certain things were going to happen? So we said, okay, let's do some further investigation and model the rate of negativity. We wanted to investigate a possible relationship between online sentiment and real world events, such as process in an exploratory sense. We use something also known as change point analysis to detect particular changes in the basically trend. Again, here is some of the Python code for it. And this is this code. What we notice at some particular points, the sentiment, the negativity rate increased or decreased, and we could actually relate it to particular events, which was interesting because sometimes the sentiment was really peaking and then it slowed down after events, and at other times it actually was the cause of increasing certain events. Now, causation and relationships also a dodgy thing. We cannot just make any conclusions because we have a relationship. So again, from this study, then my PhD is on fake news surrounding the COVID-19 data, particularly in a South African context. And I wanted to do this approach rather than a lexicon-based, was using machine learning. So firstly, what is fake news? According to Alcott, they describe fake news as news articles that are intentionally and verifiably false. The Council of Europe actually then goes further and categorizes this into 3 subcategories: disinformation, misinformation, and malinformation. Now, disinformation is information that is false and deliberately created to harm a person, social group, organization, or country. Now, it's deliberately false and intended to cause harm. Misinformation is information that is false but not created with the intention of causing harm. So sometimes somebody just didn't understand something clearly, but posted it that is actually really they're misinformed, but they don't intend any harm, although harm may come out of it. Malinformation is information that is based in reality, but is used to inflict harm on a person, organization, or country, like some certain scandals, or the Gigaba example is one of them. It can go sometimes to the vaccine cases, etc. So there's some of the data sets that's used to create the model. I actually got it from other researchers that annotated it, published it, and made it available. Also supplemented with some Google fact check, PolitiFact websites. We got a total of 36,254 data points remained. Now, these data points are text. So to model it requires certain feature engineering and processing. So if you look at the model diagram, on the top part is basically where we got the data from Twitter, and we did some feature selection engineering, pre-processing. The bottom part is where we trained the previous 36,254 points, and then we applied in the model. And this is basically based on balance accuracy, we got the light gradient based machine classifier to be the preferred machine learning model. Now, at this point, you might be asking, okay, the conventional machine learning approaches, but the state of the art at the moment is transformers, attention networks. Well, it requires a lot of resources, GPUs, which we do not have. I particularly do not have. And to get it, you need to use some online cloud platforms. I tried it on something known as Paperspace Gradient. You pay a certain fee. One thing it notices, it gives you high accuracy, but at the cost of speed. And to increase the speed, obviously need more GPUs, parallel computing, handle big data to actually process, because I'm going to be processing approximately 1 million tweets. So I needed something that was lightweight and with a satisfactory accuracy. In this case, it seemed light GBM classifier was the way to go. So it's a decision tree type, short for light gradient boosting machine. It's a free and open source distributed gradient boosting framework for machine learning. It was originally developed by Microsoft. It's based on decision tree algorithms and used for ranking, classification, and other machine learning tasks. Here is this the particular formula that it goes through. And then here is the code that we kind of ran the algorithm through. There's some fine tuning with the estimators, and we applied the model, and then here is a plot of what was fake versus not fake. It's almost directly proportional. Again, it's with the accuracy at that particular time of 80 somewhat %. Now, we did all this work. You might ask, or you might come across, how did we get to it working with text? That's straightforward. So there is a field known as natural language processing. So what is it? Natural language processing, or NLP for short, is broadly defined as the automatic manipulation of natural language like speech and text by software. It like converges between computer science, human language, AI. If you look around us, we've already probably encountered, integrated, and use it on a daily basis for spell check, auto-generated video captions like YouTube, and obviously our smartphone, the smart portable devices such as Google Assistant, Siri, Bixby, and Alexa. So all of these technologies only exist due to NLP. And a goal of NLP is to enabling computers to interpret, analyze, and generate human language similar to or indistinguishable from that of a human. That just recalls the Turing test, basically, that aims to do the same thing. The Turing test, originally called the imitation game by Alan Turing in the 1950s, is a test of a machine's ability to exhibit intelligent behavior equivalent to or indistinguishable from that of a human. So if you just look at the diagram, basically the C is the person that's judging whether whatever I've received comes from a computer or a human. And when it reaches a point when you cannot make that decision, then you pass the Turing test. So there are two components of NLP, known as natural language understanding and natural language generation. Now in NLU, natural language understanding, it helps the machine to understand and analyze human language by extracting the metadata from context such as concepts, entities, keywords, emotion, relations, and semantic roles. In business, it's conventionally applied to understand a customer's problem in both spoken and written language. It involves the following tasks: to map given input to useful representation, to analyze different aspects of the language, and it's considered slightly more complex than natural language generation. Look at this example: book me a flight for 8 a.m. on April 13. Is looking for the intention is to book flight, the departure time 8 a.m. April 13. So that'll be a very simple example of natural language understanding. The natural language generation acts as a translator that converts computerized data into natural language representation. It involves the following tasks: text planning, which includes the retrieval of the relevant content from knowledge base; sentence planning, which includes selecting required words, forming meaningful phrases, setting tone of the sentence; and text realization, mapping sentence plan into sentence structure. Common applications of NLG include the production of various reports, from example, weather and patient reports, image captions, and chatbots. So it basically looks at some daily weather records and it'll produce it into a manner that a human would easily understand. The differences between NLU and NLG: NLU is the process of reading and interpreting language, whereas NLG is the process of writing or generating language. NLU produces non-linguistic outputs from natural language inputs, whereas NLG produces natural language outputs from non-linguistic inputs. Some applications of NLP include machine translation, information retrieval, sentiment analysis, information extraction, question and answering, to name a few. So for question and answering, it focuses on building systems that automatically answer the questions asked by humans in natural language. For spam detection, it is used to detect unwanted emails getting into a user's inbox. Sentiment analysis we will touch on later. Machine translation is used to translate text or speech from one natural language into another natural language. And I'm not sure why this thing is doing this. Yeah. Technology issues. Speech recognition is used for converting spoken words into text. It's used in applications such as mobile home automation, video recovery dictating to voice biometrics, voice user interface, and so on. Chatbot is one of the most important implementation of NLP applications. It's used by many companies to provide the customers chat. So many times you go on the website, you will see a pop-up chatbot typically. Information extraction is for extracting structured information from unstructured or semi-structured machine-readable documents. So think of your PDFs, etc. You'll try and get information from there into a structured manner. Now, there's considered a general pipeline for NLP. It's sentence segmentation, word tokenization, stemming, lemmatization, identifying stop words, dependency parsing, part of speech tags, named entity recognition, or chunking. So sentence segmentation is basically you have a continuous paragraph, for example, with many sentences in between, and then you segment each sentence. You get it, for example, in an array of each sentence being particular input. If you look at a code where I wrote, Nimisa is hosting an event on the 15th of February. It will be held in Durban at the Coastlands Hotel in Umhlanga. Prof. Estakur will be presenting at this event. Please don't miss out on this opportunity. It segmented each sentence into 4 sentences. Word tokenization is basically taking each word in a text and tokenizing things, making it singular. In this case, if you look at natural language processing, it takes natural on its own, language on its own, processing on its own. And if we were to do this, for example, in Google Colab using Python, this is the particular code that you would use. The text was Namisa is hosting an event on the 15th of February. And it's basically tokenized each of these words, and it detected around 10. So word tokenization is sometimes not straightforward. You can use rules. You can tokenize on punctuation. You can tokenize on white spaces. You can use regular expressions to tokenize on whatever pattern you wish. There's also stemming. Stemming is similar to lemmatization, which we'll cover next. It's basically, if you look at the word change, changing, changes, change, and changer, it tries and finds the root word, but not a word that is in the dictionary. In other words, if you look at the word that it finds, it's C-H-A-N-G. It probably sounds Chinese, Chang. A particular library to use from the NLTK Snowball Stemmer. I give an example of the students played games until midnight and arrived tired to write their exams. I'm looking to stem this sentence. Different stemmers like pod stemmer, etc., might do this differently, but follow the similar pattern. It produces an output: the student play game until midnight and arrive tired to write the exam. Now the AARRIV is not a real word. Whereas in lemmatization, it finds the same thing, but the root word has particular definition in the dictionary. And again, the same example, just this time importing WordNet lemmatizer. And the output is the student played game until midnight and arrived. You notice it's not ARRIV, it added an ED, so that word exists, tired to write the exam. Now, if you think about it, all this is useful when you have variation of text saying the same thing. And when you're trying to analyze it, you want to get everything in particular consistency when you're trying to do some type of text classification or sentiment analysis or any of that sort. So again, stemming versus lemmatization, I mentioned the difference. Other things you need to look at is identifying stop words. Stop words sometimes, because it appears so frequently, depending on what you're using, might unnecessarily have a high frequency in the text when you're trying to do certain tasks. If you look at the sample text with stop words, Geeks for Geeks, a computer science portal for geeks, the output is remove the word, the letters A and the word for, and just has Geeks for Geeks, computer science portal geeks. Similarly, the other two sentences, it removed B and it removed I, and so. And if you look at the related code for this, you can put the stop words, you can even add stop words to this. So the example is, this is a sample sentence that shows how the stop words filtration, and it removed is a, and, that, and so on. There's also something as dependency parsing. So this is where it starts getting more complex, because the other ones you probably could do it straightforward. But how do you find meaning? How do you want to teach a machine? Like, okay, in this case, deemed universities charge huge fees. Huge relates to what? It relates to huge fees, and then it's dependent on charge. Then universities also is dependent on charge, and deemed is dependent on charge. So it's a step forward at that particular time to try and make machines understand relationship between words. In this case, you have the adjective, the noun, verb, and you have others. This is the code using Spacey, which is basically industry type level of package for natural language processing. If you haven't explored it, I urge you to do that. So I wrote, he is interested in learning natural language processing. It give me the dependency passing of it. And there's something known as part of speech tags. So when we say something, certain things are nouns, certain things are verbs, certain things are verb in the singular sense, and so on. So that will basically what part of speech tagging is. It tags the part of the speech. And here is the abbreviation, what you see here, PRP, VBZ. Here is an extended of what each one means. I'm not here to teach English, so a lot of these things I don't know myself. But you can have a look at it. The other is, sorry, this is the code for it. You tokenize, and then this is again using natural language toolkit to find specific tokens. The other thing I mentioned is named entity recognition. So the ousted WeWork founder Adam Neumann lists his Manhattan penthouse for $37.5 million. So what named entity recognition does, it tries and looks at particular words or entities in this case, and try and recognize them in particular categories. Like WeWork is an organization, Adam Neumann is a person, Manhattan is a location, 37.5 million is monetary value. And using Spacey, you could do this. I gave the example, Nimisa is hosting an event, followed the same previously, and it picked up the Nimisa an organization, it has a date, Durban is a particular location, Coastlands Hotel is an organization. And then there's something known as chunking. Chunking is built on top of part of speech tagging. It's a process of extracting phrases from unstructured text, which means analyzing a sentence to identify the constituents, noun groups, verbs, verb groups, etc. However, it does not specify the internal structure nor their role in the main sentence. So it basically groups all verbs together, and the nouns and stuff like that. And here is a particular code for this. Now, there are certain approaches to NLP. You can use the rule-based, you can use machine learning, the traditional machine learning, and then you can use deep learning, which has recurrent neural networks, long short-term memory. You have the transformers. Both traditional machine learning and rule-based approaches works on word level. They don't address the sentence level NLP task in terms of context between two sentences and the sequence of words in a sentence. There are still improvements needed to understand context and ambiguity using deep learning methods, and sentence length increases. So as with language, it gets more complex. How does the machine going to know what we say? It needs to understand how words relate to each other, what word means. For example, even sometimes properties of words, which it's more complex to develop, like, ice. If you put it in a certain temperature, it's going to melt. And if you type a sentence, Simon put ice outside in summer, what is going to happen? The machine must know that ice will melt. Those type of things require, in this case, like deep learning type of solutions. So there are some useful models, pre-trained models that we can leverage to do some of our tasks. We can use pre-trained models to solve our own NLP problem instead of building a model from scratch. Pre-trained models are designed to solve specific problems and need some fine-tuning. So they save a lot of time and computational resources when compared to writing a new language model. NLP language models are available in several pre-trained categories based on their function. And the saving of your time is key here. A lot of these, like the OpenAI chatbots, ChatGPT, the BERT, Transformers, and Hugging Face had Facebook's, I'm not sure which one it was, but with all the resources and GPUs, they were still training it after a week or 2 weeks just to get to a particular checkpoint. And that's with all the resources that they have. You as an individual researcher, or maybe as a small team, it wouldn't be feasible for you to begin training this. You might not even have the resources, or even if you do, it might just take you too long. So you need particular checkpoints and downstream your language model. So some of the top 10 pre-trained NLP language models for AI application building, right in the number one is BERT, and a lot of it in the top 10 is a variation of BERT, which is a bidirectional transformer. Google uses this a lot. In fact, I think it was developed by them. At number 3 is OpenAI's GPT-3. You have T5 that makes it an Electra. Transformers it's a technical discussion, and hopefully another day someone else can discuss that in more detail.
Meet John, a talented programmer who is looking to start a company that used his personally developed mobile application to connect restaurants and customers for booking and reservations. Even though the app was ready, John had difficulty getting together a team for his startup, needing separate people for sales, marketing, programming, content creation, and customer support. Hiring reliable manpower while being strict with his budget was getting difficult. He reached out to his friend Ryan, who said John could start his company without hiring any new people, thanks to just a single AI-based tool. John couldn't believe it, which led Ryan to introduce ChatGPT, the revolutionary AI chatbot being developed by OpenAI. It is a state-of-the-art natural language processing, or NLP model, that uses a neural network architecture to provide responses. This means that the ChatGPT bot can answer questions without being explicitly told what the answer is using its own intellect, unlike previous AI chatbots. So, how does ChatGPT help John in filling out his team? Regarding sales, ChatGPT can provide full-fledged sales pitches based on the correct prompts. It can provide tips on how to pitch your product to businesses, removing the need for sales training. Completely customized to your requirements and your prompts. If you don't like some things about the response, you can ask for certain changes, and the chatbot will make sure they are done. When it comes to marketing, ChatGPT can provide efficient marketing strategies, which can help new entrepreneurs learn how to market their products to prospective clients. It can provide trending keywords that marketers can use for SEO purposes, while providing ad copies for your website and blog. Speaking of websites, since John can do a lot of the heavy lifting and programming, ChatGPT can help proofread the code and help out when looking for bugs to fix. Apart from basic bug fixing, it can also provide sample code structures for different programming languages, allowing John to focus more on improving core functionality and workflow, rather than fixing basic code errors. Websites and blogs content is very helpful in gathering potential customer leads. The revolutionary bot can provide full-length blog posts with near-perfect fast accuracy in seconds, allowing further customization, like choosing the length of the subject matter to the complexity of language. For John's customer support, the bot can draft complete customer service emails based on the situation, saving time and resources. The tone of the message can be changed to reflect the nature of the message, creating an efficient alternative for call center professionals. John was left speechless seeing this level of versatility from ChatGPT and wanted to implement it right away. However, Ryan made sure John knew about some drawbacks of the chatbot before getting started. Since the bot is trained mostly on data up to 2021, many of the newer events may still need to be discovered by ChatGPT. Even basic stuff like asking about the current date and time is beyond its scope, much like the limited understanding of context despite providing near lifelike solutions to certain problems. Even the accuracy of many responses can be questioned since the AI model is still learning and being developed.
So this is a state-of-the-art one example, ChatGPT. It's being improved and probably going to be rolled out sooner with Microsoft Edge. It'll be up to date, but obviously we wouldn't have access to their code. So I mentioned we're going to speak about sentiment analysis. Previously, another researcher also discussed it. So let's do it in a little bit more elaborate way. So what is sentiment analysis? It's the computational process that determines the mood expressed within text, images, videos, and audio. It's opinion orientated. It's positive. It has three classifications: positive, neutral, negative, sometimes binary, positive and negative. If you look at the figure on the right, it usually takes in an input and it goes to a tokenization, stop word filtering, negation handling, stemming, classification, and the sentiment class. Now, that's just a generic process. So if you look at this three, it provides the sentiment for positive way. It says, my experience so far has been fantastic. Your support team is useless, which is negative. Maybe telecom, I don't know. The product is okay, I guess. It probably is it's indifferent between whether it's positive or negative. Important sentiment analysis to understand. It is instrumental in understanding public perception. In engagement, it helps in better engagement between companies and customers. It helps improving the research and development of a particular product service that the company wants in market. So consider trying to manually analyze the sentiment expressed for a day on social media. It's virtually impractical and realistically unrealistic. Sentiment analysis is an automated solution that can analyze and process large amounts of data and perhaps provide near real-time results. So if you look at the figure on the right, for the essential digital headlines for as of July 2022, for a population of 7.98 billion, you have active social media users on the right, 4.7 billion. Almost 59% of people are active users. And even if they post one thing a day, that's 4.7 billion data points. But realistically, what I'm sure you'll see what's being posted in a second or in a minute, that famous infographic. Unfortunately, I don't have it here, but it's so much of data. It obviously is a big data phenomenon, the velocity, veracity, variety, value, and so on. Yeah, if we just take an example of how maybe sentiment analysis will work, say we've developed a sentiment analysis classifier that just reads certain text and it's going to classify this paragraph. We've vetted the classifier, we are happy with it. So here's an example. The printer does everything promised in the product details. The packaging is very user-friendly, so I easily lifted it out of the box. But the user manual is just way too simple. Not everyone is computer or printer savvy. They need to give better instructions on certain things. So let's try and highlight what is positive. You figured out that does everything promised is positive. The object in question, printer, very user-friendly, positive. Again, the object is packaging. Okay, that's positive. What is the negative aspect? The user manual is way too simple and need to give better instructions. So overall, this text out sentiment will what we are going to do for demonstration's sake is we're going to take the extracted sentiment by taking those positive words, does everything promised, all the way to need to give better. For the printer packaging, user manual instructions. And we're going to provide some certain scores. So based on our algorithm, which in this case is a black box, it says +3 for the top one, +2, -2, -2. And our algorithm just does a simple arithmetic calculation and says the overall sentiment is positive. Now, this is a simplistic example just to demonstrate how a simple classifier might work in sentiment. Obviously, it gets more complex. And it even extends to audio, video, and images. If you look at Barack Obama, it was real-time computer vision. It can analyze the sentiment and from each sentiment also extract in a positive way, whether it's happy, etc. Google has a site where you can upload an image and you can test out what it will predict with certain levels of confidence. I uploaded just a random picture and it says, well, very likely this is joy with a confidence of 100%. So you can classify images also in sentiment. Here are some interesting NLP apps. Your social searcher with Streamlit also, and Chat GPT at the bottom. Some basic NLP libraries to consider for simple tasks in Natural Language Toolkit, TextBlog, Gensum, Spacey, and Stanford NLP. Some of them handles neural networks, like Spacey and Stanford. The others don't, and some of them are best for NLP prototyping right up onto business production, which is Spacey and has 50+ languages available for tokenization. So that's the end of the presentation. Thank you. And do you all have any questions? There's no questions. There's a question there.
Oh, okay. So over the years, we've seen how quantum mechanics has produced their findings of quantum teleportation, right? So my question to you is that, do you think, like, when it comes to NLP, we should rather start looking at quantum NLP, or we should rather like look at the other libraries that Python utilizes? Like you just shown us the example of Stacey, which also excel at large amount of data. So would you say it's recommendable if, like, going forward to explore more libraries that can handle like large amount of data, or we should just rather like look at the quantum NLP?
So obviously it depends on the context. If you ask me to get you some water and I bring you the river, obviously then it's just giving you too much of something that you don't need. So these other packages are like what we mentioned, Spacey, and still be relevant for some certain tasks. Now, when you're going into quantum computing and the technology as it increases, the benefits of quantum computing is that it can process a lot of things very quickly. So it probably it'll be useful when you need to create more complex NLP tasks, sort of like how a human is able to understand its whereabouts, communicate based on the contents, the mood of the people, handle many situations at the same time. Then obviously you need technology to handle this, and quantum computing is one of the options. So I hope that answers or gives you some information. Yes, Professor.
Can I just complete? Can I just add to that?
Yeah.
Look, the thing is, to a hammer, everything looks like a nail, right? So, when you hold a hammer in your hand, everything looks like a nail. So be careful about going down the route of quantum informatics when you're trying to solve a particular NLP problem, because you're adding complexity onto complexity. And you also need to understand your background. If your background is computational computer science, then I have no problems. As long as you have at least an honors degree in maths and an honors degree in com science, you will enjoy that journey. But if you don't, rather stay away from quantum informatics. I know the QI guys are going to kill me for saying that, but you have enough complexity in NLP on its own without adding to that. So please be careful. Pick your battles. Thank you.
All right, thanks, Yassen. I think that was quite interesting. For mine, just curiosity, because the NLP LLM, it also has a language generation mode. Do you think a time will come when machines will create their own language, which we humans will have to learn?
So I remember when you mentioned that Facebook saga of where people could understand what the machines are communicating. I'm not too sure how to give you a definitive answer, because you probably could, and we wouldn't be able to understand. But the communication between machines, like in IoTs, would be a more efficient way for them to process what's happening around them. Although we might not understand what's ones, zeros, or however they decide to communicate, and however we program them to communicate would. But in terms of us trying to understand not only machines, but our world around us, like with animals and stuff, we need then the system to give us the output into ways we can understand. So yes, will probably be a learning curve for us to bridge, maybe, like for example, we have these workshops to understand computers and data science much better. So we have an idea how certain things, the jargon surrounding AI and stuff like that. So we will have to learn, and also we cannot just leave the machines just to communicate without us knowing what's happening. We need to have an oversight, and in natural language generation, we'll have to make the computers probably provide output in a way that we can understand. Because in anything, you can even between humans to human, if you ask a statistician about a particular thing, it can give you an output that the next man, might be a meteorologist or something, would not understand what you're saying. But it's because it's lack of context, lack of jargon. So you need to learn, and as I think we are researchers, we're always learning, and if that time comes, I always give the benefit of the doubt to humans. We can learn, and we will learn, and we will adapt. So however the world is going, we will adapt, and we will learn how to integrate with the machines, if that tends to be the case. Yes.
Yassen sent a very interesting link to me just this morning. Instead of us preparing for this talk, we started looking at this. Sana, you're going to like this. So using natural language processing and the audio capability of natural language processing, not words and tokenizing words, but tokenizing words that as they are spoken. There's an algorithm out there that is now tokenizing whales talking to each other. So now they're now starting the whales with, and then my first question to him was this within species? And he knew I was going to ask that. He said, no, it's just now between species. So that is a profound development, that now using natural language processing to tokenize a species communicating with us, and we're now starting to try to understand what they are saying to each other. And they're triangulating it with external world events, like for instance, a tornado approaching, or a storm approaching, or a shoal of fish approaching that they would want to, it's food or something like that. So that's the first point. The second point, Hasana, is that computers talking to each other, right? We know the notion of compiled code. So we know that notion when you compile a language or software that you wrote is actually, it's internalized. The CPU understands it and the register understands it. So the CPU and the computer works together to analyze that. Then you take the notion of parallel computing. You have many computers understanding the same compiled code. You see where I'm going with this now. Imagine we start taking NLP and reaching that level of compiled code. I think we're closer to it than we imagine. We have this notion of M2M already, right? So yeah.
Thank you. Mine is a bit controversial as usual. My take is on sentiment analysis. The beauty of artificial intelligence is prediction. And whenever you are from that background, and I don't see how your system predicts, I become a little bit worried, if not, yes, I say worried. Now, let us go to sentiment analysis. For example, you had a very good example where you had the final result, which was giving you a positive 1. Then my question, yes, I've got positive 1. After grouping the positives and the negatives, then what? Because my reason of doing research is after using this method, I'm supposed to do A, B, C, D. So after using sentiment analysis, and I've come up with those results, so what? Thank you.
So is a question, what's the use of sentiment analysis, or what's the use of a specific
Where
approach?
do we go next after getting those results? For example, after your example, after getting a positive 1, what next?
Okay, if I understand the question, so what next would determine why we're doing sentiment analysis in the first place. So if I'm looking, for example, I want to know public perception of my brand, of my new product, for example, MTN's new rollout promotion. What are people speaking about it? So will calculate sentiment analysis. Now, just ignoring the example I presented because I mentioned is very simplistic and it might not apply to that case. You would use an approach that is satisfactory for production level, and it will provide you the feedback to say that, you know what, you have certain percentage of users that says positive things about it, and what are those positive things they're mentioning about it. You can then categorize, you can find particular objects or aspects from what is positive versus what is negative, and you can try and find a triangulation. Okay, this is what they find good about the product, what they find negative about the product, and so on. So in the first bit, I don't know, I have trouble couldn't understand the first bit of it, but I hope that is what was asked, or maybe my answer explains certain aspects of your question. So let me pose this in a different way. If you want to know the sentiment about your product and you've grouped what's positive and what's negative, what then is the issue? I'm just trying to figure out, why would you go down a path to do sentiment analysis unless you already know why you're doing it? So you have a problem statement and stuff before that. So obviously, I'm not standing here with a particular problem statement. I'm just showing you what can be done in a generic way. So if you have a problem statement to know how is my service delivery as government level, on a particular location, about a particular mayor or something like that, what is happening, what are people saying about it, not only on social media and the newspaper. So you're going to harness all this unstructured data, and then you want to try and find the mood expressed in it. And not only the mood, what entities, what is, comes out from this mood, what are they talking about, what are the issues are. So firstly, you will then, the first filter would be then to find out the sentiment analysis. Firstly, it filter into what is negative, neutral, or however you want to do it. It can extend beyond those three categories. And then you'll find out, okay, I know my customer says, these are the negative points, service delivery standards are poor, this particular road is never fixed, etc., etc. So that's going forward, taking the data. I can then use my resources in a more meaningful way than other than just jumping into the sea, not knowing what people are saying. So I tried to
Yassen, let me help you there. So it's not a case statement, and it's not an if then else statement. Okay, so it's not binary, and it's slightly trinary. It's a tuple from that point of view. But when you have a series of negative sentiments and positive sentiments and neutral sentiments, think of a movie. Somebody likes a movie, somebody definitely doesn't like the movie, and somebody is ambivalent about the movie. You look at the positive ones and you start cross-marketing other movies for the people that like them. Think of Amazon. People who read this book like that book. What are you doing? You're marketing a particular genre of books to a particular set of people. If the people don't like that book or don't like that movie, you don't market that type of movie to that person. So it is just making the set of data into three distinct, mutually exclusive, positive, neutral, and negative. But you really need to think about your data set. That is why you need to understand your data, start with the end in mind, what you're trying to get out of it. But we can discuss this more offline.
Thank you for your presentation workshop. I had two questions, but the first question, I think you answered it when Samuel asked a question. But the second one is it's a simple one, it's a short one, but I think it's a complex one. I'm always interested in sentiment analysis in a multilingual country like South Africa. And if you look a lot of tweets where people don't tweet in English, or when there's a lot of code switching that happens, how do you deal with that in a country like this? Because I think we invest a lot in languages like English, and there's a low investment, particularly with data sets, like very low data sets when it comes to indigenous languages and other African languages.
So what you mentioned is, and where in particular contexts and locations like South Africa are the challenges of NLP. So you need to build data. The data is a new oil in AI. So one aspect of it is getting data, hard raw data, such as indigenous languages that we have. So then we can then use it to manipulate it. There are translation services in the interim where, for example, Google offers certain ways of where you can translate this to this, but with translation, context sometimes is lost, right? So certain things that we understand in colloquially might not go down well in the translation. So we build on that, and we always, that is why this is not we reached the plateau of data science or NLP. We're still growing, and part of what you mentioned is what we need to do to grow, especially in South Africa, is to integrate what we South Africans have that is different to others, and to make AI more locally climatized. Hopefully that answers the question.
So in your work, what kind of challenges did you face with that?
We had data which they had mixed languages. So some of them had English and the other languages, Afrikaans and so on. The algorithm is this delimitation of the study, of the limitations, is that it focuses only on English, right? So to circumvent that, what you could have done is try and translate other languages to English and then do the sentiment analysis. But you're going to get mixed results. It might improve your overall by a few percentages if you want to go down that route. But what you mentioned, having those data banks of actual languages for Zulu and Xhosa and everyone else, that's invaluable. And that's why some of these services like Google and Microsoft, they tell you you can use our stuff for free in inverted commas. But what are they taking from you? Your data, which is what they need. So that's, you get, there's a pros and cons to this thing, but thank you for your question.
In the Fees Must Fall data set, there were about 16,000 tweets from different languages. We did a language detection on it, and we worked out. In fact, there were some tweets in Chinese as well, if I remember correctly. So there were about 18 languages that we found, and 16,000. Remember, when you're aggregating your data or searching or scraping the internet for the data, it scrapes by the hashtag. So we were looking hashtag Fees Must Fall. We weren't looking for English hashtag Fees Must Fall. We just scrape by fees must fall or fees must come down, and a few other keywords. So we weren't biased toward English. We just recognized that English was in the majority in that particular case. Thanks.
Okay, thank you, Prof. We've got a question online from Dr. Latif. Okay.
Asking on behalf of someone online. He says I should ask the presenter to describe the process they used to determine that their data followed a normal distribution, a log normal distribution.
Okay, so we have data which has particular timestamp. In this case, we group them according to months in particular chronological order, with the frequency of tweets, the volume in that aspect. So based on volume, you plot it against a time, and you get to see how it looks. And more often than not, it will look like a log normal. No, I did a particular test, log normal test. You get statistical tests for this. It's not part of the presentation, but I did log normal tests, other distribution tests as well. And you get, obviously, with the null hypothesis and alternative hypothesis based on a particular significant level, 95% confidence level, said that, you know what, it's a
And
log
the
normal.
other interesting thing was that not only was the log normal distribution prevalent in the first wave of viral tweets, so fees must fall went on for a few years. So on the 15th of October 2016, there was a log normal distribution from October till about November. And then on the anniversary, the 15th of October 2017, there was another log normal. So it actually repeated itself, although the wave was much, much smaller. You know, you had 200, 300,000 tweets in 2015, and you had like 100,000 tweets in 2016, and so on. It started in 2016, and then you had about 100,000 tweets in 2017. So it did replicate itself. So not only did we prove that it was log normal for the initial burst, but we also proved that on anniversaries it existed as well.